In this video, we're going to look at two examples of running linear regressions. So in number one here, it says the table shows the test scores of 5 students and the number of hours X each of them studied. Okay, so if you look at our table here, we have X hours, so 0, 1, 2, 3, 4. That's the number of hours they were studying. And then Y equals the score they got on the test, so 64, 73, 82, 90, and 94. We want to make a scatter plot, and then we want to find the line of best fit. So I'm just going to scale this 1, 2, 3, 4, 5, and this is going to represent the hours. Okay, so this is the hours that they've studied. And then the vertical axis, because it starts at 64, I'm going to bend the axis. Okay, that just means I'm skipping a bunch of numbers. And then 50, 60, 70, 80, 90, and 100. And once again, that's your scores. Now, when we make a scatter plot, we're really just plotting each of these points. So the 064 is a point, the 173 is a point, and so forth. So we just estimate where those are. So 064, I'm going to say is about right there, a little less than halfway. 173, once again, just a little bit above 70 there. 2 and 82, 3 and 90, and then 4 and 94. Okay, and once again, you can see that this is tracking to be linear, and we have a positive correlation, right? As the hours went up, the scores went up, so we can see that there's going to be a positive correlation. Now, to find the line of best fit, we're going to ultimately use our calculators, so I'm going to talk you through kind of the steps that we do. So the first thing we need to do is turn our diagnostics on, and to do that, you want to click second and then 0 at the bottom of the calculator. This takes you into the catalog, and it's in alphabetical order. We want diagnostics on, which starts with a D. So if you click where your alpha button says D, do you see how there's a little green D there? If you click that, it'll skip you down to where the D's are in the alphabet. And then we can just scroll down to the one that says diagnostic on. You have to hit enter twice until it says done on your calculator. Once you've turned the diagnostics on, then you're ready to start the problem. To run a linear regression, we need to get the data into our calculator. Okay, so to get the data into our calculator, we're going to click stat here. It's right off the cursor pad. If you click stat, we want to edit because we want to enter our data. So we're going to hit enter. You'll notice that I've already put the data in here. So you put the X's, okay, your X numbers go in L1 and your Y's go in L2. Okay, you want to make sure that the tables end at the same spot because every X should have a Y value associated with it. If you don't, it's going to give you an error. Once the data is in your calculator, you're going to go back to stat. And this time you'll notice how edit's highlighted up above. We want to calculate now because our stats are in our calculator. So we're going to cursor to the right over calc. And then we want to run a linear regression, which you'll notice is the fourth one down. Now you could click 4 on the keypad, or you can scroll down to where 4 is, hit enter, and then once again you have to hit enter again. This gives you the line of best fit in equation form. You'll notice that it says y equals ax plus b. That's the same thing as y equals mx plus b. The a is the slope, and it tells you it's 7.7. The b is the 65.2. We're not going to worry about the r squared for now, but the r value is our correlation coefficient. So to answer question A, where it says find the line of best fit, we're going to write down this equation. We're going to plug in the numbers for A and B. So we get y equals 7.7 x plus 65.2. It says identify and interpret the correlation coefficient. Once again, that's the R value. And we have that R equals 0.99. Okay. Looking at that R value, we can see that it's positive and that it's very close to 1. So in the interpreting piece, we would say that this gives us a strong positive correlation. And then lastly, it says predict the score if the person studied for 1 hour. That means we're going to plug 1 into our equation. So we're going to get y equals 7.7 times 1 plus 65.2. Now, every once in a while, I get asked the question, Mr. Gogol, how do I know if I should plug the number in for X or for Y? The way I remember it is I look at the units on the number. So you can see that it's 1 hour. If I go back up to my table, I see that X is hours. So this has to go in for X. And then I can just calculate it using my calculator. So 7.7 times 1 plus 65.2. And I get Y equals 72.9% is the grade that we would predict.